Hello guys and welcome back to our YouTube channel. So in this video, we are going to answer the Northwest Regional Mock 2024 question 1. And the question with the first F on the current carrying wire at right angle to a magnetic field is given by the equation F equals to B or F equals to BIL, where I is the current, L is the length of the wire, and B the strength, the magnetic flux density. What is a homogeneous equation? From A. B. Show that the above equation is homogeneous for 6 marks. So we have been given that F equals to BIL, question 1. F equals to BIL, that is the force. F is equals to force, it is perpendicular to B. The force is perpendicular to B is F. Then we have B, the magnetic flux density. Magnetic flux density. I is a current. L is length of the wire or length. Now we are asked to show that this equation is homogeneous. They also ask us to define what is an homogeneous equation. A homogeneous equation is an equation whose terms on the left hand side has same unit as the terms on the right hand side. For example, if I have the equation, let us say S equals to UT plus 1 half AT squared. Now this equation have to be homogeneous if the unit of this left hand side have to be equal to the unit of all of this right hand side, right? So the unit of each term here, so about the unit of the left hand side is simply distance, which is meters, and then for the right hand side, unit for u is meters per second, unit for time is seconds, plus this is half is dimensionless, the unit for a is meters per second squared, unit for second is second squared, right? Now we now see this seconds is cancelling, the second square which is on the bottom cancel with the second square above, and we are having meters equals to meters plus meters, or I can say meters into 1. Meters is equals to 1 plus 1, all that meters. So you see, here we are having something in meters, here is something in meters. Forget about the 2 that you have here. So the problem is now we are having the units of the left hand side equal to units of the right hand side. Some people say that the unit of all the additive terms have to be the same. That is, the unit of this term is meters, unit for this term have to be meters, unit for this term have to be meters. That is what is meant by an equation which is homogeneous. Correct. Okay, now we are going to show that this equation is homogeneous. How do we start? So we start by saying unit of left hand side, and these are abbreviations that are allowed for you to use in your exam. Left hand side with respect to and things like that. Right hand side as well. So unit for left hand side is unit of left hand side will be equals to unit of F. And that from Newton's second law, F equals to ma. And from here we see that when we talk of making equations homogeneous, please, we are saying that you should come and have this. Let us say we are going to give you have this thing: mass, length, time, temperature, current. I think this is the 5 that you can master in physics, or you can say luminous intensity, mole, what amount of substance. This one is in candela, CD, candela. This one is mole with L without A. This one is for current. We have amperes, start with in bracket capital A, name of a person. Time, seconds, in bracket small s, and the dimension is T, if you like to put the dimensions. Here is capital A, here is CD, here is mole, it is small m. Then we have the length, meters. When you talk of length in physics, we are talking about meters. I forget about kilometers, small m. And the dimensions is simply big L, something like that. Then for mass, we have kilograms. The dimensions is capital M. So you can use either the dimensions or the base unit, anyone you use. So we have base unit, dimensions, we have quantity. Okay, so this is when they say Schroeder equation is homogeneous. If you are using the base, you make sure you show that this on the left hand side have to be that this on the right hand side. So we now try. We have F is a derived quantity made up of mass and acceleration. So we want to find the units of F. So we now for the unit for mass is among here. So there is many for acceleration. So we'll go further and say acceleration is change in velocity over time. And we now get this one now will be mass. I can say change in velocity. I can just call it V, big V over t. And another velocity is distance over time, or length over time. So length over time, another time. So we are having m l on t squared. I can now go ahead and substitute it in the form of mass, length, and time. Mass is kilograms, so unit of F has to be equals to mass, which is kilogram. The length is meters, and the seconds is on the bottom per second squared, and that is that kilogram, meters, and second. You just use among this. So that's the unit of length. So we want to make sure that the unit of this left hand side have to be this. And when you have this, you already have maybe 2 marks out of the 5 that is remaining, 1 for definition. Now the units for I, unit of I, which is current, is ampere. I is among here. Unit of L is length. It is among here. You put your meters. Now the unit for B will not be what you have to do. Unit of B. Some people will go and make B the subject here and determine. If you use this equation to determine, you have no mark for you the unit of B, B1. So you determine the unit for B. You can use any formulas. We know that B equals to F equals to BQV. This is the equation that shows where B is the magnetic field, F is the force, Q is the charge particle, maybe E of an electron, then V is the speed of the electron moving in the magnetic field. So this is the equation. So we can say from a B will be equals to F on QV, and the unit of B will be equals to unit of F on QV, unit of all of that. And the units for F is force. We just had it updated to be kilogram meters per second square. And Q is simply equals to IT, current times time, or Q dt equals to I equals to dq dt. If you cross multiply, get dq equals to I dt. So the unit of q equals to the unit of I dt, which dt is time. So it, which is second. So we have in ampere second. And the unit for velocity v is meters per second. We had it up there, meters per second. I simplify this, you get kilogram on ampere. These seconds will go with this second, it will cancel. Meters will go with this meters, it will cancel. So we're having kilogram ampere on the bottom, then per second squared. So we're having kilogram per ampere per second squared, kilogram per ampere per second squared. Now unit of right hand side will be equals to unit of BIL. Now you now substitute the units for B. The unit for B is kilogram on ampere second squared. Multiply the units for I is ampere. The units for L is meters. Right? Then you see ampere cancel with ampere. You have kilogram meters. The second is on the bottom. You can put second squared. So and you have in the units for left hand side to be kilogram meters per second squared. So it says since you conclude since unit of left hand side is equals to unit of right hand side. Hence, the equation F equals to BIL is homogeneous, because that's what they ask you to prove. You conclude is homogeneous. You have all your 6 marks. So it is very easy. So we just try to express it in this form, and you really look for formulas. Formula booklet is also allowed. You can still get the unit for B by using other formulas. So any formula in physics that you know. So thanks for watching and have a great day. Please subscribe to our channel, like, share, and if you can support us, here are our numbers. If you have any worry, you can still contact us on WhatsApp. And we have groups where we help students a lot, about thousands of students. You are free to post your worry, and a lot of engineering students that are there. Here's our email address, and I am the CEO. Teach physics, math, further math, and chemistry, computer science. Thanks for watching and have a great day.